I know that so science class, you guys have been learning about earth science, you've been learning about layers of the earth, you've been learning about how earthquakes and volcanoes and all that stuff happens because of the interactions underneath and on Earth's surface, right? And so we have finished our models, or at least we finished the physical building of the model of our regions, right? And you guys got data on where the earthquakes are, where the volcanoes are, where the different landforms are, yes? Okay, so let's talk about what your job is for today. Your job for today is to really start understanding why those earthquakes, volcanoes, and landforms are the way they are, okay? Why those patterns are there. And it's not just because you're on a plate boundary. I know you guys know that, but you guys knew that coming into it. So what we cannot do is we cannot say, like Colin has the Himalayan mountains, he can't just say, okay, this mountain range is there because two plates are crashing into each other because, duh, we've known this, right? Probably since you were pretty little. What Colin needs to think about in this model is, let's take it to that next level. In Colin's model, one thing that he found out was that those Himalayan mountains kind of do something weird. If you look at India, the land in India is very flat, and the land in Tibet is very flat. But the land in Tibet is like, what, 25,000 feet higher? Is that right? Yeah, it's the Tibetan Plateau. So it's not just that there's mountains in between them, it's that there's mountains in between them, and then the northern land is like way higher, even behind the mountains. So that's going to be one of Colin's explanations that he has to formulate. He has to formulate why that plateau is higher. He also is going to say, he also found some data about how deep earthquakes were. You guys all should have found that data as well. You've got to start figuring out why some earthquakes happen at deeper levels than others, okay? So, today is going to be all about formulating explanations for the tectonic activity in your region, okay? And it's going to go way deeper than what you've learned in class because we're looking at this really specific area and applying what it's learned, okay? So, a couple things to do. Two things. Number one is we are going to get out those charts that you used, that you collected your data on. And the first thing I want you to do is just go over that data. I actually have some data recorded as well. I just jotted down some things I knew about each area. And so I do want to, at some point today, compare that to yours and make sure you have all of the things that you should have about your region. The other piece is to do the research and find out why that stuff is happening in your area. You can use whatever websites you want to use. You can use whatever books you can find in the library. I have put 3 new websites on our Weebly site, the mrswallingford.weebly.com. So there's 3 new sites on there that you can use that will give you some more information. And I will give you a hint. The first piece of it is figuring out what plate boundary you're on and what kind of crust you have. So are you convergent, divergent, transformed between oceanic or continental? Okay? So that's going to be the biggest piece of it. Let me think. From there, you guys need to have a really strong explanation formulated in 1 week. Okay? We're not going to have another pull-out session in this next week. So you have today, and then you have any time that Ms. Schooler decides to give you in class to figure out what's going on in your region. Okay? Because the next time we meet, we have to have that explanation done, and we're going to finish up our models, put in colors on it, and label it, and be ready to present. Yes? Yeah. We're going to have one more day after this. Okay, what questions do you have about what you need to do today? Any questions? Yes. Can you go get Hannah? Yes, we'll get her in a second. What else? Nothing? Okay, so what are the 2 things you're going to do today?
Lily Hobbs, please come to the office for early dismissal.
Yes, sir.
Find out what boundary your place is on.
Okay, what else? Explanation why it's happening, but that boundary is part of the explanation. So what's the other thing you're going to do to compare with me? Compare your charts to mine. So make sure you're going to compare your chart to mine, and then we're going to figure out the explanation. Yes? You can record it however you want. You can collect it however you want. But that's about it. Questions? Okay. So you guys can move to a computer and get to work. Great. Yeah. Okay, so tell me, let's take a look at, well, first of all, tell me overall, what have you figured out so far?
There's a lot of islands near Japan. Yes, and it says there's an earthquake reported every hour in
Okay.
Japan. And Oh, it's like this volcano itself is actually roughly the size of California, but it has a population that's 4 times as much as California.
Okay, tell me a little bit about like the shape of the islands. Is there a
Most of them are just like scattered around, like it's kind of scattered. It's scattered like because there's the volcanoes underneath them. So they're mostly like around this area. It comes down along. It's all along this side here.
so they're kind of in this arc, kind of a line in an arc.
They follow the shape of Japan.
Okay, they follow the shape of Japan. Let's take a look at your notes. Let's kind of compare them to what we've got so far. Did earthquakes?
We don't quite have everything in there.
Okay, tell me about what you found offshore, because I know on your model you had.
There's a really deep trench, and it's like I think that's like almost 5. It's almost 5 miles below sea level.
Okay, you need to write that down, because that's really important. Oh,
We just kind of
you ran out of room. Okay. Let's see. What about?
Mount Fuji itself hasn't erupted for like I think 100 years.
Okay. So you have some dormant and some active volcanoes?
Yeah.
Okay. What about, do they follow any pattern?
Not that we found yet.
If you were to zoom out from your area, what kind of pattern would you notice?
Yeah, I know. Well, most of the volcanoes were towards the middle. I think they kind of are scattered to the day boundaries.
Okay.
Because whenever you look at this one, it's like right there. Follows the plate boundary.
So you see it follows, so the
Because we found
volcanoes.
most of our volcanoes were here and like right here.
Okay, and so that would kind of tell you. Now, when you zoom in, where was your plate boundary? Was it on the island or was it offshore?
It was off the it's like right.
Okay, so it looks like are they mostly to one side of the plate boundary?
They're mostly over here that we
Okay, that sounds like a really little thing, but that's actually going to be important. So what you're going to want to think about as you formulate your explanation is these really nuanced things. So here's your plate boundary. The volcanoes are to the left or to the west of the plate boundary, and then where was the trench?
right here.
So kind of to the right, like right along the plate boundary to the right. Okay, so you're going to want to find out if that's true. Okay, so those are the things you want to think about. So why is it that the volcanoes are all along one side of the boundary, the trenches along into the other side? And that's the kind of thing you want to be researching. Okay? Okay, you guys are good to go. I think you have all the data you need. Okay.
So we just need to figure out how the boundary and the trench.
Yep, you got it. Okay.
I feel like it zoomed in.
Well, that would be
Yeah,
better.
we're gonna get some maps off the
Okay. And then
we're trying to get through this whole letter right on every single thing.
Okay, and then look at the Jules Verne Voyager website. It's on my Weebly site. Check that one out too, because that'll give you some more. Yeah. Okay. Colin, just keep working. I want you to kind of do what you've been doing with the map, so I can get that filmed.
Wait, did you take a picture of me? They put there's a hot spot.
Okay, and so what is that map showing you?
It's showing that India is a lot lower elevation. The plateau that's north of the mountains, and then the mountains is taller than it all.
Okay, so that's what we were talking about in the group before. Okay, and then what about the earthquakes and volcanic eruptions?
There's not.
There's not any. Wait, there's no
Or
earthquakes?
no volcanoes.
There's no volcanoes.
Yeah. And then the earthquakes, there's a lot all around the mountain chain and
Okay.
stuff all over.
This one gives you good elevation data. There's another website on the Weebly page called Jules Verne Voyager. I want you to check that one out because it's going to give you more accurate earthquake and volcano data. Okay, so go to the Mrs. Wallingford.weebly site.
What's the URL?
Mrs. Wallingford.weebly.com. Okay, so Tyler, what are you working on right now?
Finding the elevation of the earthquakes.
Okay, the depth of them. Okay, so the Jules Verne Voyager might be better. So go ahead and click on current projects. And then it's that very first, yes, second link, sorry, in that very first entry. There you go. Click on that. And you can do the same thing we did on the other one. You can zoom in, and then you can click on earthquakes, and you can kind of see the depth of them, okay?
At nighttime, it just flips over.
And then once you do that, I want you to see, so you've got your model out. What are some of the things that you want to make sure you explain about your model? Like, what are some of the things you've noticed?
Here.
Yeah,
Okay.
and it's like it's surprisingly it's lower than the rest. It's,
Okay.
It's below even sea level. If we did make it in that, but it should be below sea level, and it's lower than everything else in this valley. And it's like sort of like a line that goes all through here, and you can see it like cuts through this too.
Okay. Have you guys figured out what kind of plate boundary you're on?
I think it's like
it's the African plate.
And then the Eurasian one goes like right.
It's like right here.
But of the three, what are your three types of plate boundaries?
Convergent, transform, and divergent.
Divergent. Okay, so convergent, transform, and divergent. So
I'll go and search that.
I'll search it.
you're gonna search it now.
Oh, okay, but I'm gonna do earthquake depth. So like, what's like? Should I say what's important about earthquake depth?
Well, let's think about searching online. When we search online, we want to do a keyword search. We don't want to actually type in questions, right? So you just need to type in your keywords. What are your keywords?
Earthquake depth.
Yeah, because when you type in questions, you end up with like ask.com and Yahoo Answers, which are not reliable websites. Okay. Okay, and so what are you going to be doing?
I'm probably gonna look up what type of plate boundary the African plate is.
Okay, if you had to make a prediction right now, the fact that you have a deep, deep valley bordered on sides by mountains, what kind of plate boundary would you say?
Tough one. I'm thinking.
What? You think divergent? Let's see what you can find out, okay? Okay, so what have you guys figured out?
Why the trench? There's this is a subduction zone.
Okay, so tell me what that means.
Where the trench is. It's where like two plates, like one goes underneath, right? Yeah. Yeah, one goes underneath another plate, and that's probably why there's a big trench here.
Okay.
And then we found the convergent plates right here, and that's where most of the volcanoes, and that's where Mount Fuji.
Interesting. Okay, so you've got a subduction zone offshore, and then you've got a convergent plate boundary onshore where the volcanoes are. Okay, the other thing I'm wondering is, do you understand or know why one plate subducts under the other?
Because the one that stays on top has a lighter density than the one that goes underneath.
Okay.
So whenever they meet, instead of like pushing up, like the ones with equal density, the one with heavier density sinks down. While
Okay,
the other one,
which one has heavier density?
the one that goes underneath.
But specific to your region, which one?
Yeah.
The Pacific plate? Why do you think that has more density than that Asian plate?
Because whenever you
Next steps. That's what you need to figure out next.
the arrows point this way,
Okay, but
so that means that there.
okay, so that's how you know that one subducts. The question is why?
Because it has
Why does the
larger density.
But why does it have a larger density?
Because that's how it was made. That's just how it is.
Okay, that's not a good enough answer. So that's where your research goes next.
Okay, so why does the Pacific plate have a higher density than the ocean? Whatever that
Yeah.
plate.
Okay.